Assalamualaikum warahmatullahi ta'ala wabarakatuh. How are you? Everybody okay? All right. So welcome back to our class after 1 week break due to the flooding. And I pray that anybody, any one of us who was affected by the flood, recovering well. But, of course, it takes time to fully recover, but we need to move on. We need to continue with our studies. We need to continue with our class. So today we are going to finish up this chapter. I'm going to do the last part of that chapter. That would be the last part, I think 14.4. 14.4, the topic is on Lagrangian multiplier. So I will open up my notes first and see what, where are we? We are here. Second. Oh. Okay, so I think we were done. So we are done with that part, and I will continue with a new. Apa lagi kena buat? Oh, okay. Share screen. Share screen. Recording. Dah lama tak buat kelas ni, lupa dah. Okay, recording dah siap. Recording. Recording okay. Share screen. Alright. Okay, boleh nampak screen? Okay. Alright. So first announcement, like I said in the WhatsApp, we will have our test on Wednesday. Please make sure try our best to come to the test. Don't make excuse anymore. Okay, excuse is finished. Without valid reason, there is no excuse. So our test would be the 29th. So midterm 29, and the time is 8 p.m. Now the coverage is the same as I mentioned earlier. I will not cover any new topic, okay? There will be no new things that will be included in the test, will be the same as what I said earlier. So that will be good for you, you don't need to put any new things on the partial derivative. So make sure I'm, I hope you have studied enough, since we postponed the test. Okay. So, apa lagi nak cakap? Anything, any question, any comment, anything before I start that topic? Apa-apa? Anything? Tak ada ya? Alright. So, what I'm going to do today? Saya kamera off ni. Kamera off lah. Kamera off lah. Did you?
Yes, sir.
Kamera
No
off.
camera.
Macam no on balik? Ada apa ni? Kamera off. Recording on. Recording on. Kamera. Apa pasal dia off pula? Ini ya? Itu dia. Sahaja lah benda ni. Okay. So the method that we're going to do today is about optimization problem. Optimization problem. Berapa banyak lagi? Optimization problem. So optimization problem is similar to the linear programming problem. where you have objective function. So you have a problem, you maximize, and objective function subject to a constraint. Here, the constraint is a function. Okay, so constraint is a function. So you have two functions. One is the constraint function. The other is the objective, which is also a function. And the problem can also be minimized. So it can be minimized or maximized. So you minimize objective function subject to a constraint, or you maximize objective function subject to a constraint. So in terms of the problem, it's similar to what you have in the linear programming topic. Just that in the constraint, you have a system of inequalities. Here you have functions. So that is the problem. And we're going to do this by the method, what you call the Lagrangian multiplier method. So multiplier method is the method that you're going to solve this optimization problem. So we use Lagrangian multiplier method. So this is what you're going to do. Now let me state this problem more specific in terms of functions. So I will write down here maximize objective function. Okay, objective function denoted by z is equal to a function of x and y, subject to the constraint, which is also a function g of xy equal to k, where k is a constant. So k is a constant. So that is our problem. And then you can also have minimize. Okay, so we minimize the objective function z equals to f of xy subject to the constraint g of xy equal to k. So it can be maximized or minimized. Now, how do we solve the problem? We're going to solve it by Lagrangian multiplier method. So first thing, you need to define the Lagrangian function. Okay, Lagrangian function. So from the objective and the constraint, we come up with the Lagrangian function denoted by L that will be equal to the objective f of xy plus lambda. Okay, lambda they call it multiplier, multiplied by the constraint g of xy minus k. Okay, so that is our Lagrangian function. So what you do, we essentially combine, right? You combine the objective, which is the f of xy, and the constraint g of xy, okay, equal k, by introducing that multiplier. So the lambda is the multiplier. Lambda is the multiplier. That's why we call it Lagrangian multiplier method. In the Lagrangian function, you have a multiplier that's lambda. And the other thing that you do, the constraint, okay, the constraint, we rewrite the constraint. You have the constraint g of xy equal to k. So what you do, you simply bring the constant to the left, then you have g of xy minus k equal to 0. So that is the part that we put into the function. So you just rewrite the constraint in that form. Okay, all right. So now, how do you solve the problem? When you want to solve the problem, you want to find, okay, you want to find the value of x, y, and lambda, but yeah, we don't need lambda for us. X, y, that solve the problem. What is our problem? Problem to maximization problem. solve a problem, either, okay, either you maximize the objective subject to the constraint, or you minimize the objective subject to the constraint. So that is the problem, all right? You want to find the X and Y that solve the problem. Example, solve the problem that maximize the objective subject to the constraint, okay, whatever the constraint is, g of x, y, or if it minimize, then minimize. So to make it short, okay, to make it short, we just say solve the problem. And we know the problem is what? The problem is either maximizing the objective or minimizing the objective subject to that constraint. Okay, so you want to find the solution. You want to find xy that solve the problem. So in other words, you want to find the solution. So the x and y is our solution, or you can call it optimization. Optimization point, optimum point, optimum point. Okay, optimum point. Okay, correct. Now, how do you solve the problem? So you solve the problem, we are using the partial derivative. So first thing, we are taking the first partial derivative. We call this FOC. FOC meaning first order conditions. So first order conditions is the condition for the critical point. So it's like finding critical point, you know. It's like you find the critical point. So you call it FOC. That means we are going to take the first partial derivative with respect to the different variables. So FOC, what you need is what? Number one, you take derivative of the Lagrangian function with respect to x. All right. So you take derivative of L with respect to x. So what do we get? We get the, you look at the Lagrangian function. Okay, go look at your Lagrangian function. You take derivative with respect to x. What do I get? I specify our problem yet. No, I didn't. Oh, sorry. I have to specify that specific Lagrangian function. So sini lah. So you have to refer to this one. Refer to that function, this function here. So that is our Lagrangian function. That comes from the problem. We maximize or minimize the objective subject to that constraint. So you have already the Lagrangian function. So you want to solve the problem. We focus only on the Lagrangian. So first partial derivative, Lx, take derivative of L with respect to x. What do I get? The first function f of x and y. So you got derivative of f with respect to x. And then the second term, I have what? I have g of xy minus k. So g of xy multiplied by the lambda. So you take derivative of g with respect to x. Set that to 0. So call it number 1. Okay. Now, secondly, you take derivative with respect to y. Tapi langsung tak stable. The derivative f of xy, take derivative with respect to y, I got fy plus lambda multiplied by derivative of gxy minus k with respect to y, that will be gy equals 0. So that is our number 2. And thirdly, I take derivative with respect to lambda. What do we get? I get gxy minus k equal 0. So let's go back to the Lagrangian. Now, one way to do the partial derivative, how do we get lambda gx, lambda gy, and the partial derivative number 3? How do you get it? So just look at the constraint, all right? You look at the constraint. So you have is lambda multiplied by g of xy minus a. So one way that you can do, just to get the idea, you write or you multiply the lambda with the terms in the bracket. So I got lambda g of xy minus lambda k. So if you see it in that manner, probably you can see the idea better. So g of xy, g of x, g of x, lambda gx from the equation number 1. So you take the derivative with respect to gx. Okay. So what do I get? I get lambda, which is the coefficient of g of xy, g of x and y. Then you take the derivative with respect to x. So that's how you got lambda gx. And similarly, when you take the derivative ly, what do I have? I have the lambda multiplied by the derivative of g with respect to y. So I got lambda gy. So that is number 2. Now for number 3, L lambda, you take the derivative with respect to lambda. Now here is lambda, just lambda. So the derivative of lambda is 1. So you got gxy. Here there is another lambda. Okay, negative 1. So negative lambda, I'm sorry. And then the derivative is negative 1 multiplied by k. So I got negative k here. So that's how you got the partial derivative. Okay, any question? So make sure we know the conditions, all right? We know the condition. We take the derivative with respect to lambda, with respect to y, with respect to x. So we label them as 1, 2, 3. So we're going to make use of this 1, 2, 3 to solve for x and y. Okay, to solve for the optimum one for x, y. So we're going to use that 1, 2, 3. Now, how do we proceed? Firstly, you consider 1 and 2. Now, are you done? I want you to write down this. If you don't write down, just look at the screen. Unless you are very smart. If we are not, then you don't know what's going on. So I want you to write. Are you done or you're not done yet? Siap ke belum? If you're not done, I will wait for you because this method is important. Udah siap belum? Udah siap? I need only one person to say yes. Siap ke belum?
Yes.
Okay. So you're done. Now, how do you do that? So you make use of 1 and 2. All right. So from number 1, what we do, you write lambda. Okay. You write lambda in terms of the other terms. Okay. So what is the other term? The other term is you bring the fx, the gx to the right, then you will have the other terms. Okay. So what is it? Lambda is equal to what? Is equal to negative fx over gx. So from number 1, you got lambda equal to negative fx over g of x. And then from number 2, again, you write lambda in terms of all the other terms. So you go back to number 2, what do we have? You have negative fy over gy. So that is equal to negative fy over gy. So here you have lambda equal to something. Lambda is equal to something. So what? So therefore, negative f of x over gx equal to negative fy over gy. So positive, negative, negative become positive. So you got this. From here, all right, from here, you will have x in terms of y, or y in terms of x. Doesn't matter. So you will end up with only x and y. Either you have x in terms of y or y in terms of x. That is your choice. Then what do you do? Substitute into what? Substitute, say, okay, x equal to g of y, but it can also be y in terms of x. Into what? Into number 3. Okay, don't substitute back into 1. Okay, if you substitute back into 1, you do it until kiamat. You will get the solution. Okay, you put into 3. Okay, you put into 3, then you will get the solution. You put into 3, you do some work lah. Then you got the x, and then you got that y. So that is, broadly speaking, the method. Okay, so make sure we understand the method. First, 1 and 2. Okay, 1 and 2. You write lambda in terms of the other terms. After that, the first term is equal to the second term because both of them are lambda. Okay, and then you get x in terms of y or y in terms of x. Substitute into number 3, then you got the solution. Okay, all right. Now that is the first order condition. It's similar to the critical point. Okay, so what you get here, critical point. But sometimes, sometimes critical point even is just a critical point. But if the problem is maximized, then sometimes we just conclude that is the maximum point. If the problem is minimization, then we just conclude that is the minimum point. Okay, sometimes you just do that. But there is a second order condition. So the second order condition is the second partial derivative. So you need the second partial derivative to make sure it's a maximum or minimum. Now, this will involve a matrix. So you are going to find a bordered, we call it a bordered Hessian matrix. I just give you the matrix, and then we will come back to this part here when we cover the topic matrix. So that will be at the end of the semester. So we denote by HB, and that is equal to the following. Equal to 0, gx, gy, gx, lxx, lyx, gy, lxy, lyy. So it's not difficult to remember, because if you see it here, first row 0, 0 gx dy. So sama. That way same. Okay, first row, first column, same terms, 0 gx gy. And then the other 4 terms, you have lxx, lyy, and then lxy, lyx. So that's not that difficult to remember. So what you need is what? The second partial. So you take the derivative of the L with respect to, Lx with respect to x, and then I take derivative Lx with respect to y, and then you take derivative Ly with respect to y, you take derivative of Ly with respect to x. So these are the second partials that you need. And then you get that method. Okay? So this one hold. We hold on. Okay? Later we will come back to it. Right? So for now, we just assume that our critical point that we got from the first order condition would be as per the problem. If it is maximizing, then it's maximum. If it is minimizing, then it's minimum. Okay. All right. So let's consider one or two examples. Okay, first example. First example is in the book, but I'm not sure about it. I'll just write it down. Okay, example number 1. I think I'm going quite fast. Are you done with the matrix? Just write down the matrix. Okay, just write down the matrix. Later on, we come back. We know what we're talking about. So that is the Hessian matrix. Now let's look at a few examples. Example number 1. Suppose we want to maximize the following function, the objective, f of x equal to 25 minus x squared minus y squared, subject to the constraint, say 2x plus y equal 4. Okay, so that is our problem. Now, we know the Lagrangian function L is equal to what? Is equal to the objective plus lambda multiplied by the constraint. So you need to rewrite the constraint. Okay, so what I need is from the constraint 2x plus y equal to 4. So you just rewrite it as 2x plus y minus 4 equal 0. So that is the form that we need. All right. So now our Lagrangian will be 25, the objective, minus x squared minus y squared plus lambda g of xy. I'm sorry, you have to write the exact function. 2x plus y minus 4. Okay, so that is our objective. No, I'm sorry. That is the Lagrangian function. Okay, so now you do the first order conditions. You take the partial derivative with respect to each of the variables. Okay, so first Lx. What is Lx equal to? All right, now first order conditions. Number 1, I don't have a space. Siapa tu? Can you mute your phone, your mic? If you want to say something, go ahead, say it now. I will. If you have something to say, go ahead now. Otherwise, can you mute your mic? Okay, so you have what? First order condition, I write down here. Okay, Lx equal to what? Negative 2x plus. Here, there is another term in x, which is 2x. You take derivative of 2x with respect to x, what do you get? You get 2. So lambda times 2 equal 0. So that is number 1. Secondly, Ly, take derivative of L with respect to y. What do we get? We get negative 2y. And then you have a y here. Okay? So the derivative of y with respect to y is just 1. So lambda equals 0. So that is number 2. And can you mute your mic, please? Siapa tu? Bising, eh? And then you take derivative with respect to lambda. There is only one lambda, lambda to the power of 1. So that is equal to 1. So therefore, the derivative is 2x plus y minus 4 equal 0. So that is our number 3. Okay, can you mute? Okay, are you done? Finished? So now we are going to find the x and y using the method that I just described. All right. Okay, any question? Okay, if you have no question, I will proceed. So the only issue here is the lambda, the lambda multiplied by the constraint. So what you can do, you do this in order to get the idea. Lambda multiplied by 2x plus y minus 4. Now, in order to see how you get the derivative, let's say Lx, what do you get? Lambda 2. Because here lambda is multiplied by everything in the bracket. So lambda is multiplied by 2x, lambda is multiplied by y, lambda is multiplied by 4. Okay, so that's why I got lambda 2. 2x is 2, and then multiply by the lambda. Now, if you don't get it, one way to see it is you multiply the lambda throughout. So you got lambda 2x plus lambda y minus lambda 4. Okay, so if you do that, then you can see. Then you can see here you got x. Okay, So derivative with respect to x is 1. So what I get lambda 2. So that is Lx. That's how we got lambda 2 for the x. And then for the lambda Ly, okay, Ly, what I have is lambda y. So you take derivative with respect to y, what do I get? I get 1. So lambda times 1. So lambda, okay? So that's how we got it. And then when you take derivative with respect to lambda, here I got what? Lambda 2x. So derivative of lambda with respect to lambda, 1. So 2x. And then here I got lambda y, take derivative with respect to lambda, 1. So y. Okay, and here lambda 4, take derivative with respect to lambda, 1. So just get 4. So that's how we get L lambda. All right, so that is our number 3. So now, how do you do it? So make sure we follow the method. Firstly, you have to use what? You have to make use of 1 and 2. Okay, make use of 1 and 2 to get x in terms of y. So from number 1, what do I get? I get lambda equal to what? 2 lambda equal to 2x. Therefore, lambda is equal to x. Betul ke tak betul? Tengok balik. So saya next. So 2 lambda equal to negative 2x. Okay. So lambda is equal to apa saya video ni off lagi. Okay, all right. Now from number 2, what is lambda equal to? Lambda is equal to 2y. You bring the y to the right, you will get lambda is equal to y. So from number 2, lambda is equal to 2y. So lambda equal to x, lambda equal to 2y. Therefore what? Therefore x is equal to 2y. So you got x in terms of y. Or if you want, you can have y equal to 1 over 2x. So either way, it doesn't matter. It's up to you. Okay? You can write x in terms of y or y in terms of x. Now let's say I keep that one up. I keep x equal to 2y. So what you do next is we substitute x equal to 2y into what? Into number 3. Okay? So number 3, what do I have? I have 2x plus y equal to, I write down the equation first. Plus y minus 4 equal 0. That is what you do, what you have. Okay, now you substitute x equal to 2y into that thing. So what you get is 2 times 2y plus y minus 4 equal 0. So what is it? You will have 5y equal to 4, y equal to 4 over 5. Okay, so you got y equal to 4 over 5. You want to find x. So to find x, what do we do? Substitute. Okay, so you substitute y equal to 4 over 5 into what? Into number 3, or you don't have to. You just do it into 2 into x equal to 2y. X equal to 2y, that is equal to what? 2, 4 over 5. What is it? 8 over 5. So our solution is x equal to 4 over 5. I'm sorry, x equal to 8 over 5, y equal to 4 over 5. So that is our optimum point. So the optimum point, kita selalu guna x dulu. X is equal to 8 over 5, y equal to 4 over 5. So that is the point, the value of xy that maximize the objective. subject to the constraint. Okay. Any question? So that's how we do the thing. Now I give you another example. Okay, another example. Though. Okay, I give you another example. So that would be example number 2. Okay, example number 2. Okay, are you done? Finish? Finish? Okay, I give you example. Yes. Okay, good. I give you example number 2. You have a problem here. Maximize the objective equal to 3x squared plus 5y squared minus 2xy subject to a constraint which is x plus y minus equal to 5. Okay, now I want you to find the x and y that solve the problem, right? So you want to find x, y that solve the problem. Okay, so I want you to try now, okay? First, you have to find the Lagrangian, get the Lagrangian function, all right? And then you get the first order condition. So 2 things I would like you to do, and then I will discuss. You get the L, and then you get the first order condition. Okay, so do it now. I give you 3 minutes. So after somebody has completed the first order conditions, let me know so that we can proceed. Okay, so I just want you to do up to the first order conditions. Take the Lx, Ly, L, lambda. So you have to do it. Okay, doesn't matter wrong or right, because I'm going to go through it afterwards. So I want everybody to do it. Okay, now go do it. I'll give you 3 minutes. After that, we will proceed to finish it up. Okay, you got it? Okay, do it. I'll give you 1 more minute. Okay, you got the first order conditions? Okay, so first, you write the Lagrangian. So sometimes it's good to write the general form first. You know, the Lagrangian, what is it? F of xy plus lambda equal to g of xy minus a. So write that general form first, so that you know what you're doing, okay? And then from the constraint, okay? So the constraint, what we need to do is what? You have to rewrite the constraint. So x plus y equal to 5. I bring the constant to the left. I got x plus y minus 5 equal 0. So that is the form that we need. Now put into the function L. So what do we get? So therefore, our Lagrangian function will become, so it will become 3x squared plus 5y squared. So 3x squared plus 5y squared minus 2xy plus And that's the objective. You want to put, you put the bracket, it's okay too. But you don't have to, because the one that you put bracket is the one that you multiply by the lambda. G of x, y, x plus y minus 5. So that is our Lagrangian function. Now, get the first order condition. So what is it? Number one, Lx. So you got 3x squared, that becomes 6x. And then I got negative 2xy. So there will be 2y. And then you look at the lambda, like I said earlier, if you're not sure, you multiply lambda by each of the term, so that we will get the idea. But when you are already good, then tak payahlah. Then you got what? X. So lambda x. So you got only lambda equal 0. Right? Number one. And then take derivative with respect to y. You got 5y squared, that will be 10y. And then you got negative 2xy. Derivative with respect to y, that will be negative 2x. Again here, lambda y. Lambda, and then you got y. Derivative is 1 multiplied by lambda. You got lambda. That is number 2. Take derivative with respect to lambda. That will be what? Derivative with respect to lambda is 1. But 1 is multiplied by everything in the bracket. So that will be x plus y minus y equal to 0. Oh, like what I did earlier, you multiply everything by the lambda, then you get lambda x plus lambda y minus lambda y. You take derivative with respect to lambda, you'll get the same thing. Okay, everybody got it? Okay, so now I want you to continue. From 1 and 2, you get the lambda in terms of x and y. So let's see. The first person who get x in terms of y or y in terms of x, you let me know, so that I will continue. Okay, so do it now. Get x in terms of y by using 1 and 2. Okay, anybody get the relationship yet? Anybody get from 1 and 2, you will solve x in terms of y or y in terms of x. Now, how do they relate? Anybody got it? Tak siap lagi ke? Okay, berapa dapat? Y in terms of x, or in x in terms of y. So it doesn't matter. Which one? Okay, first person who get it, let me know. Cepat. Tak apa, salah pun boleh. Salah pun okay, doesn't matter. I want you to get it. Okay. Cepat. First person who got it, let me know. I just need one person. Kan? Tak apa buat ke? Tak seberapa. Takkan tak seberapa. I need only 1%. Okay, if you get the solution, let me know. What is it? Just x in terms of y. You don't have to find, don't have to substitute into number 3 yet. Okay, we just go step by step. Okay, anybody get it? What is it? Cepat.
X equal to 1.5y.
X equal to 1.5y. Okay, in terms of fraction, 1.5 apa? 1.5 x is equal to 1.5. 1.5 apa? Fraction before you get 1.5. Apa dia? 2 over apa?
3 over 2.
3 over 2. Okay, so 3 over 2. So you got 3 over 2y. So that is the relationship. Okay, x in terms of y or y in terms of x. Now let us see. So like I said here, from number 1, you write lambda in terms of x and y. You bring the x and y to the right. So lambda is equal to 2y minus 6x. Okay? Okay. And then from number 2, I get lambda equal to 2x minus 10y. So lambda is equal to 2y minus 6x. At the same time, lambda is equal to 2x minus 10y. So therefore, from there, okay, therefore, 2y minus 6x equal to 2x minus 10y. So you bring the same variable to one side, the other variable you bring to the other side. So let's say, I think the easier way, you bring the y to the left. So you bring y to the left, I got 12y. Equal to, you bring the x to the other side, that will be 8x. Okay? So if you write x in terms of y, then you will get 12 over 8y equal to x. So 12 over 8, that will be 3 over 2. So 3 over 2. So I got x equal to 3 over 2y. So from there, you can write y in terms of x. That will be okay as well. So if you do that, then y will be equal to what? 8 over 12x. That means 2 over 3y. So somewhere, all right? Okay. So that is the relationship between x and y. Now what you do next is you substitute into number 3. Okay? Okay, by now I think some people already substitute in number 3. So if you substitute into number 3, x equal to 3 over 2y, or y equal to 2 over 3x, okay, then what do you get? What do you get? The x and the y? Y equal to 2 over 3x. Or x equal to 3 over 2y. Or you use 1.5 like our friends. So let's say we substitute. Apa tadi? X equal to 3 over 2y into number 3. Okay, number 3 is x plus y minus 5 equal to 0. So what do I have? I have 3 over 2y, which is x, plus y minus 5 equal 0. So 3 over 2x plus, no, I'm sorry, 3 over 2y plus y. So you got 5 over 2y equal to 5. So y equal to 5 times 2 over 5, that is equal to 2. Okay? All right. So y equal to 2. To find x, substitute y equal to 2 into, you can put into 3, but you don't have to, because I already have that relation, that simplified relation. So x is equal to 3 over 2y, or y equal to 2 over 3x. Then you put it there. Substitute into x equal to 3 over 2y. That will be just simply equal to 3 over 2 multiplied by 2. That is equal to 3. So here cancel. So I have a point x equal to 3, y equal to 2. So we say that the optimum point is, we can say xy equal to 3, 2. Or you can say x equal to 3, y equal to 2, maximize the objective. The objective yang tadi lah. Okay, objective subject to the constraint. Constraint as per the question. Alright, so that is our conclusion. Okay, any question? Okay, good. Now I will give you another example, because there are a few types of function, that is commonly used. So I give you another example. So this is example number 3. I have here maximize an objective function f of xy equal to x to the power of 3 over 4, y to the power of 1 over 4, subject to constraint for x plus 2y equal 50. Okay, I want you to solve the solution. Okay, and not solve the solution, solve the problem. Solve solution. Anybody solve the problem? Okay, do it now. So you do from the beginning until the end. Okay, I give you 10 minutes to do this. So do it now. Oh, okay. Anybody get the solution yet? What do you get? Y in terms of x or x in terms of y? Berapa? Y in terms of x or x in terms of y? Wih, nampak mendung kan gambar? Gambar, it looks like cloudy, very cloudy. Anybody got it yet? Y in terms of x, berapa itu dapat? Okay, stop. Okay, stop. I will go through. So you got the problem. Lagrangian function. What is it equal to? L is equal to the objective. X to the power of 3 over 4, y to the power of 1 over 4, plus lambda multiplied by 4x plus 2y minus 50 equals. So you rewrite apa ni? Okay, rewrite the constraint into that form. Bring the constant to the left. So I got the L function. L to write L cantik sikit. Bukan L. You don't write L like that. Okay? Bukan L macam lesen L. You like the L, you write the L is like the L tulisan sambung. You know, cursor, like the cursor L. So make it nice. So that is our L. This one is correct. This one is not correct. So you got the L, the Lagrangian function. First order condition. What are they? Lx. Take the derivative with respect to x. So I got x to the power of 3 over 4. Now don't throw that y, okay? Because y is a constant. So I got 3 over 4 multiplied by x, reduce the power by 1, that will be negative 1 over 4. Don't throw the y away, okay? Y is a constant coefficient of x. So y to the power of 1 over 4. Plus, I got 4x there. So lambda 4 equal to 0. So that is our number 1. Now Ly, take the derivative with respect to y. So what do I get? I get 1 over 4. X, 3 over 4 is a constant. And then y, reduce the power by 1. That becomes negative 3 over 4. And then I got 2y. Take with respect to y. So I got lambda 2 equals 0. So that is our number 2. Now L lambda, everything in the bracket. Or you multiply lambda into each of the terms. So we got f2 4x plus 2y minus 50 equal 0. That is our number 3. Okay, so that is our first order conditions. Now, if you got it wrong, please make the correction. Okay, make sure you check this is the right one. So you check yours, and then make sure you know where is the mistake, so that you can make the correction. Okay, so make sure you know the mistake. If you throw away that y when you do the Lx, that is not correct, because y is a constant and y is multiplied to the x. Okay, so treat it like a coefficient to the x. So that is our first order conditions. Now you use 1 and 2. Okay, so I'm asking you again. If you proceed, okay, like I said earlier, now what you get? Y in terms of x? Or x in terms of y? Kakak seorang, betul dapat? It doesn't matter. You can be right, you can be wrong. Okay, but that is not the point. The point is, I want you to do it. Okay, what is it? Anybody got it? Just let me know. Whoever you are, just tell me x in terms of y or y in terms of x. Ay, tak rasa berapa ke? Hah? Tak berapa? Nobody get the. At least you try, then you get whatever you get. So anybody get to that part? X in terms of Y or Y in terms of X. Begitu. Saya sebenarnya, I don't want to call your name already. You know, I want everybody, if you do it, just tell me just, you know, senang cerita. It doesn't matter whether it's wrong or it's right. Okay, Tuan Muhammad, what do you get? But nobody answer, I got to call your name. Okay, cepat. What do you get? Syarifah Khadijah. Nampak aja saya kena call semua orang. Syarifah Khadijah, apa dapat? Hai, Abu Bakar mesti tahu ni. Okay, what do you get, Abu Bakar?
Lambda 4 equals to x at 3/4 x minus power of negative 1/4 y power of 1/4.
So y in terms of x, y equal to berapa? Simplify. Y in terms of x. Itu panjang tu. Simplify that. So you get y in terms of x. So what you told me is still the long part. Okay. What we want is just x in terms of y. Y equal to 2x, 2/3x, apa lah. So simplify balik.
Okay, I haven't simplified yet, sir.
Okay, go ahead, do it. Okay, Nur Farhana, what do you get?
So I still can't find the answer.
Okay,
I simplify it.
I don't want you to get the answer. I want you to get y in terms of x dulu. Okay, the answer we'll do it after that. Okay, all right, good. Okay, Nur Azlina,
Yes,
cepat, you get. Hah? Tengah buat ke? Oh, tak apa. I wait for you. Okay, anybody get the solution? Not the solution. Have anybody get y in terms of x or y or x in terms of y? Alright, Sarah pula. Saras. Did you get it? Ain dalili. Dapat? Salah betul tak apa. You know, I'm not talking about right or wrong. I'm talking about you get the simplification. Okay, Ain. Tak ada. Okay, Taha Abdul Latif.
I'm still, sir.
Okay.
Still trying to figure it out.
Alright. Okay, Syarifah. Syahira pula. Syahira. Bagus juga. I call your name. Nur Alia. Nurul Alia. Nurul Izati. Actually, I have it here already. Okay, from here. So what you need is just you rearrange the terms in 1 and 2. Then you will get x in terms of y. All right. So we are already there. Tak ada siapa dapat lagi. I need only one person that get x in terms of y. Okay, Cheng Zhen, you got it? My Cheng Zhen. Syami Matul. Okay, Muhammad Aziz. Muhammad Aziz, tak dapat tak? Okay, Nurin Najwa. Ni, seorang lagi ni. Nur Soleha. Got it? Okay, so if you do that from number 1, what do we get? So you have to be careful, okay, because it involves power here. So from 1, what do we get? From number 1, you got what? I got 4 lambda equal to what? You bring everything to the right. So negative 3 over 4 x to the power of negative 1 over 4 y to the power of 1 over 4. Right? So that comes from the LX, okay? X to the power of negative 1 over 4, y to the power of 1 over 4, multiplied to 3 over 4. So you bring the 4 to the other side, okay? I just write it here. So you bring the 4 to that side, so you got that 4 here, okay? So it becomes 3 over 16. Now you do the same thing for number 2. So from number 2, what do I have? I have 2 lambda equal to negative. You have to write a bit further down. Lambda 2 equal to, bring everything to the right. So you got negative 1 over 4 for x to the power of 3 over 4, y to the power of negative 3 over 4. Okay? Now you bring that 2 to the other side, so you multiply by 2 there. So you write the step, okay? So now you got lambda and lambda. So therefore, you equate the two things. I get negative 3 over 16, x to the power of negative 1 over 4, y to the power of 1 over 4, equal to negative 1 over 8, x to the power of 3 over 4, y to the power of negative 3 over 4. So, simplify. Okay? So, anybody who are up to here, you should be able to get y in terms of x, or y, or x in terms of y. So, what do you get? Anybody? What do you get? So the negative and negative become positive. Now you bring the x to one side, you bring the y to one side. So you get x in terms of y, or y in terms of x. Okay? So which one is easier to bring? So you can bring y to the left. Okay, so I have here y to the power of 1 over 4 divided by y to the power of 3 over 4, negative. Don't forget that negative sign. Equal to, you bring the 16, 3 over 16, you bring to the right. So I have 1 over 8. Okay, so you have 1 over 8 multiplied 16 over 3. You bring the constant to the right. And then I have x to the power of 3 over 4. You bring the x to the power of negative 3 over 4 to the right. That becomes x to the power of negative 1 over 4. So now you have everything on one side. Okay? So if you look at here, here is 1, 2. So that you get 2 over 3. And then y to the power of 1 over 4 divided by y to the power of negative 3 over 4. What is it equal to? Nih, benda ni. Benda on the left ni. Berapa dapat? Berapa jadi? You have y to the power of 1 over 4 divided by y to the power of -1/4. Dapat berapa? What is it equal to? Anybody? That is just equal to what? That is just equal to y. Okay? And then you got 2/3 x to the power of 3/4 divided by x to the power of -1/4. That is just equal to x. So what do we get? We get y equal to 2/3x. Is that right? Anybody got a different solution, or you got the same as mine? So you go through, probably I do some mistake on the way, so make sure check, everything correct, there's a mistake. Okay, all right, so y to the power 1/4, you bring that thing up. So you bring that thing up, the power become positive. So you got 1/4 multiplied by y to the power of 3/4. When you multiply y with y raised to a certain power, then you add the powers. So that becomes y to the power of 1. So that's how you got y. Okay, so you add 1/4 plus 3/4, dapat 1. So you got y to the power of 1. So same thing you do it here. All right, you bring the x to the top. So x to the power of 3/4 multiplied by x to the power of 1/4. What is equal to? You add the power, you get x to the power of 1. So, to that. Okay. So you got y equal to in terms of x. So now I want you to finish it up. Okay, we will continue after Azan. Okay, so I'll see you afterwards. Okay, you got it? So you got y equal to 2/3x, and then you substitute into number 3. Okay, so I want you to finish it up. So at home, continue homework if you have not finished. So just to get the final solution. So that 3 examples. So the 3 examples that I give you is generally, normally, type of functions, normally that we see. Especially for this part, we are going to look at application sometimes, if you look at economics application, we will use function normally as per example number 3 in 3. Okay, number 3. So let's look at application. Now application, you have a few applications. Mostly economics. Okay, number 1, utility. Utility maximization. So it's a maximization of utility. And then number 2 is production maximization. And then number 3, you have cost minimization. Now, when you maximize utility, there will be some also constraint. Okay, so if you maximize utility, or in the problem of utility maximization, what is the constraint? We cannot, if you have taken economics, you cannot maximize utility infinitely. Okay, there is some limitation. Now, what is that limitation? Apa the limitation? In order for you to maximize utility, what is our constraint? Everybody has that constraint. You cannot maximize utility infinitely. There will be some constraint. Now, what is the constraint for utility maximization? Anybody who has taken principles of micro? When you maximize utility, what is the constraint? This is a real life problem. Just think of you. You want to maximize utility, you want to buy everything. But what is the constraint you face? You cannot buy all the handphones, the cars, the clothing. You can buy only what? Only certain amount. Now, what is the constraint?
Limited resources.
The constraint is your limited resources. Okay, so in utility maximization, what is it? Your income. Okay, income is limited. Resources is limited, or expenditure. Sometimes you call it expenditure. Expenditure is limited. Okay. Now, if you want to maximize your production, you want to produce as a company or as a firm, you want to produce so much things. Let's say you are selling burger, you are producing burgers. You cannot produce 1,000 burger or 1 million burger at one night. Okay, what is the constraint normally that you face in order for you to produce burger? Same constraint, right? Resource constraint. Specifically for the production, it's a cost constraint. The cost of what? The cost of our inputs. So you have the budget again here. It's income is like the budget lah, budget. Satu lagi kita budget. Budget. So sini pun sama juga. The cost or the budget that you allocate for the input. And when you are talking about cost minimization, what is the constraint? The constraint is the production constraint, subject to production constraint or quantity constraint. Okay, so you have what? You have maximization of utility. So from number one, normally you have the problem here is maximize utility subject to our income constraint or budget constraint. So that example we are talking about is example number one. Okay, so example number one. Okay, now I think our time is almost up. So I will stop here. Okay, I stop here. We continue on Wednesday. Okay, and as I said earlier, Wednesday, 8 p.m. I will test. Now, don't give me any excuse. Okay, I've delayed this. We already anticipate this thing. So no more excuse. Excuse must be the excuse that is valid by the university. If your cat is going to deliver a baby or your cousin getting married, that is not an excuse. Or you have, driving license appointment or whatever. So no more excuse, all right? Unless you got sick. Itu kena ada medical letter lah. Okay, but try your best to attend. But don't make excuse not to attend. That is not the right thing to do. Okay, so I will do 8 p.m. at night now. Class Wednesday ada juga tau. So 5 p.m. we will also have a class. Now, I will spend some time to review some of the things, to review the quiz. Okay, I will review the quiz, as well as if you have anything that you want to ask or you want to discuss, we will do it. All right, so that will be done on Wednesday. So I hope, given our constraints, the flooding constraints, some of us are directly involved and some of us are directly affected. But by now, I know it's a struggle, especially if you go to the affected area. Ulu Langat, in Selangor, Ulu Langat, Shalam, or in Pahang, you go to Bentong, you go to Bentong, you see to recover, it's also a problem, It takes time to clean up, to clear the mess. So many things involved. And I think Malaysians are very nice people. People are helping. People from all over the country are helping the victims. That's very good. You don't have to wait for the government. You know what? When my kampong was flooded, first 4 days, nobody come. Like nobody knows it's a flood. I just wonder why it take the government 4 days, and after the 5th day, tak tahu datang ke tak. Ada seorang datang. So I don't know. This year, I don't know, too slow. So people helping people. Betul lah tu, rakyat tolong rakyat. So I will. Assalamualaikum warahmatullahi taala